So welcome everyone to our video. Today we're going to talk about data security platform for Snowflake and the challenges we have in security, access control, and encryption. I'm happy to introduce you to Mike Mitrowski. Mike, take a minute to introduce yourself.
Thanks, Mike Mitrowski, Security Field CTO at Snowflake, working with our financial services and Apex customers. So the full gambit of security topics from network identity, provisioning, access control, data governance, SIEM integrations, really kind of running the full gambit to serve the security requirements of our customers.
That sounds good. And my name is Noam Dror. I run solution engineering here at SecuPi. So happy to take you guys around some of the security challenges and requirements we see within customers. So Mike, maybe you take a minute to talk a little bit about what are the challenges you see and what are the kind of the native capabilities that are already in Snowflake for the benefit of customers.
Yeah, absolutely. So one of the challenges we see is really designing an access control model that scales, and how do you enforce the principle of least privilege at scale as well? And how do we do things like drift detection and ensure that we're maintaining that principle of least privilege that, for instance, a role only has the entitlements are required, and then only the required users actually have the ability to assume that role. So in Snowflake, we have two access control models specifically around discretionary access control, which is based on object ownership. And then we have role-based access control. So that's where a user would assume a role, and then that role would have the entitlements and permissions specifically to have different access to different data objects or different platform operations. Now, the challenge we see with role-based access control is it's very easy to create an ABAC model that works at deployment. It's very difficult to maintain at scale at times. Now, usually you're doing a mapping exercise, you're building a role, which is based on a least privilege model of what are the functions and job requirements required of that role, provisioning the appropriate entitlements, and then maintaining a real strict, rigid hierarchy of the users that can assume that role and even nesting roles specifically across a Snowflake deployment. Now, what we're seeing specifically with open table formats, so things like Apache Iceberg and Hootie, moving to open table formats, customers want to get really fine-grained with entitlements and provide, for instance, entitlements based on either it's a metadata attribute or traditional attribute-based access control. So that's something that doesn't fit within a more structured and rigid, governance model of role-based access control. And then, being able to get really fine-grained with those permissioning models specifically, but also give it for a point-in-time access. Now, maybe a specific role or a specific attribute needs to be accessed, but it's not something where we want to give persistent access to. We want to give point-in-time, almost a just-in-time access model where, for a specific session or for a specific, time-bound amount of time, an attribute could be accessed by a specific, attribute-based access control model across a broad distributed system. So once we've defined, the permissions of the role, in Snowflake, the permissions of the role is always going to be the first leg of the stool, so to speak. Then underneath it, we craft an underlying policy. So the policy would, based on the conditions of that role, what access or, for instance, what confidentiality control would we be enforcing downstream? And then the tag, we often recommend your customers use tags because tags can serve really two masters. They can be used for auditing and lineage, but they can also be used for enforcement of that policy. And it's something that scales very seamlessly. So specifically under the Horizon framework, you can get very prescriptive with your policies and then reuse tags for enforcement without having to continuously create redundant policies. Within Snowflake, we have two flavors of encrypt functions. So we have the encrypt and then the encrypt raw function. So depending if a customer wants deterministic or non-deterministic encryption, the customer can choose what the ciphertext output would look like as applied to the column level. And then if customers just want a simple, regex, specifically being able to mask the data at query time, we can use dynamic data masking. So dynamic data masking allows customers to either fully mask, partially mask, set a value to null, to actually mask the data at query time as well. Now, if we want to provide a higher level of confidentiality through a third-party service, we could use external tokenization. So this is common for tokenization services or for format-preserving encryption models. Specifically where we'd make a REST call. So we'd use an external function in Snowflake terms. We'd make a REST call to a customer API gateway, call a tokenization service, or call that format preserving encryption service to actually change the underlying value that's going to be stored in Snowflake. So customers have the ability to encrypt and decrypt with format preserving encryption natively in Snowflake, or tokenize and detokenize as well. So those are really robust column level security features, really aimed at providing the confidentiality of the customer's data objects in line with their organizational policy.
Yeah.
And then also from an access control perspective, you know, in lieu of, or in addition to column level security, we can use row access policies where we can actually filter very finely grained views specifically. So instead of providing access to an entire table, we can filter and actually print a view back to the client, specifically where we're enforcing only specific rows would be returned with those row level security policies as well. And then what we see a lot of our customers using is, you know, obviously the permission of the role still being the most important thing in Snowflake, crafting those finely grained entitlement-driven policies, and then using the tasks for enforcement specifically. So those tasks can serve for lineage, those tasks can serve as enforcement, and it also allows you to get a really high level of scale under your horizon model with Snowflake specifically, where you can spend a lot of time kind of measuring twice and cut once from creating a policy, and then you can reuse those tags to enforce that policy broadly across your Snowflake deployment. And then lastly, any of these access controls and column level security features can be leveraged across Snowflake features, with the one exception of any schema and data object that requires an external function, any of those external callouts. One of the technical limitations is those data objects cannot be used in Snowflake's data sharing, but still provides a wide array of capabilities where this level of confidentiality and access control can be leveraged across Snowflake. And all of this is going to be fully auditable for 365 days through our account usage schema, and allowing customers to get really fine-grained lineage across what's happening across different dependencies within those objects, and in being able to view that natively through our new UI.
Impressive. This is pretty comprehensive and enterprise ready, I would say, right? That's really nice.
Definitely.
So taking a look at what we understand that Snowflake has, SecuPi is a data security platform that can help Snowflake customers and customers of other data platforms to do really three things: enhance activity monitoring for any kind of data access. That includes providing risk score, providing classification on the data, providing more information about the identity of the user and what attributes they have that are not necessarily inside Snowflake or inside a specific database. That would be number one. Number two is, how do we de-risk data, sensitive data in use, including attribute-based access control, fine-grained authorization, dynamic masking. That would include dynamic authorization based on real-time attribute or attributes we already know about the user and the data, and those can change with time. So that's an important part. And the last thing is around data de-identification. That would include format preserving encryption or tokenization. That would include generalization of data, especially when you want to do sensitive data analytics. Then you might want to know something about the date, but you don't need to know the exact birth date. It'll be enough to know something about the year and still get some analytical insight out of that data. And we have the ability to do that as well. And of course, apply dynamic masking, deletion, and consent-based access control. So that's kind of the high level of the SecuPi data security platform. What we see, and I think that's what we see together with customers, Mike, is the kind of challenge of how do I make sure I have some sort of a balance between two permissive roles, right? When you start an implementation, you would usually say, those are my high-level roles, and like everyone is there, and they have a lot of access rights, right? And when you do that, it's too much risk for the data, because if anyone gets control over an account, or sometimes they just have too much permissions, then you're just giving them access to something they don't need. So that's kind of the first problem. The second problem is when you're doing too many roles. And when you're doing too many roles, how would you know that? You have very few people inside each one of those roles, right? If you have just a few users inside of a role, that means maybe that role shouldn't exist there. Or when you have more roles than users, we see customers that have that, more roles than users, then you know that you have too many roles. So the challenge is, how do you protect more sensitive data with more users How do you use that hierarchical tags and more attributes that requires authorization? That's kind of the challenge. So how do you keep it simple while complying with the different regulations that you need to comply with and making the highest level of security? That's kind of the challenge we see, not just in Snowflake, in anything that requires RBAC, role-based access control authorization. So we created this data security platform to make sure you have the ability to do that dynamically. What does that mean? We can have information from your identity management and from your HR systems and from your authentication system and even from your LMS. Maybe you just need to do a certification to get access to personally identifiable information. So we can get information from those systems. We also did integrations to data attribute sources that can be the Polaris catalog, or the Snowflake catalog, a Purview catalog, the Colibra relation data catalog. So it can be different data sources, and we can also scan databases on our own and tell you what type of data we see there. Is there a PII there? Is there credit card information there? What is that type of PII and credit card information? So once we know about that, we can then create authorization policies that would say that customer representatives in North America who went through PII certification have the ability to see North American customers' data in clear text, but not for VIP customers. In order to be a VIP customer person to see that type of data, you need to be either a senior customer representative or you need to go through an additional certification. Once we have those policies, we can then apply those on encrypted data. So we can encrypt the data in Iceberg, for example, and then make sure that only the authorized users will be able to see that data. So it's an additional layer on top of Snowflake and on top of any other data source that would apply, and that helps customers to make those roles a little bit less fine-grained, right? So you keep your role-level access control as a coarse-grained access control, right? So I will give access to administrators to do administrative stuff, for customer representatives to do customer representative stuff, but I will not go into the edge cases of what type of information. Is it very sensitive PII or less sensitive PII? I will leave that into the access control policies within SecuPi. That's the idea here. And you will be able to consume it anywhere you want. That can be in your Tableau or Power BI or via APIs or anything like that. So if you'll go back to the slide we saw before, when we have the problem of too permissive or a role sprawl problem, when you get SecuPi, you can actually have a very high level of security while still keeping the simplicity and the scale of the environment. How do we do that? We enforce fine-grained access control requirements. We have policies that can use hierarchical tagging. So, for example, is it PII? What type of PII is it? Is it an email? Is it a home address? Is it a first name, last name? So we can have all those hierarchical tags into the data. We can also have those attributes about the users, for example, in real time. So we can get it dynamically from the authentication system, or we can get it in an API push, even in the middle of a session, which is pretty cool. And then client-side encryption allows you to encrypt the data without anyone from the cloud provider being able to decrypt it. So both the keys and the encryption process is not happening in the same environment, right? We have customers that have those as a requirement, a lot of European customers, and now we see that requirement more in Asia, in China, in Japan, in India. They require to have the encryption done in country, which means you can still put the data anywhere you want as long as it's encrypted, but when you decrypt it, you need to decrypt it in that specific country. And of course, we have the ability to do that. Makes sense? I'm sure, Mike, you see some of those requirements with customers you're visiting.
Yes, definitely. Key sovereign, keys local located, and then where the encryption and decryption actually occurs is becoming increasingly a common requirement for our customers.
Yeah. So now let's talk about Iceberg. So we see more and more Iceberg recently, and the reason is there is a need in the market to differentiate between the storage and the data itself versus the compute that is going to analyze that data, right? So how do I differentiate between the storage itself while providing kind of a standard for the data? So Iceberg is that new standard. Iceberg is a good standard to allow multiple engines to connect to the same data and give you the insights and the performance you need from that data. That's what we see with Iceberg today. So in order to get that, you have really two phases. Phase one is how do I create that Iceberg data? So you'll have different ingestion options, right? You'll have AWS Glue or Azure Data Factory, or any kind of a Spark streaming or a Kafka. You'll have different ways to create that Iceberg data. We can connect to each one of those ingestion engines. And because we have those plugins, we can encrypt the sensitive data even before it gets into that Iceberg format. So when the Iceberg format is created, when that Iceberg file is created, your sensitive data is already encrypted there. And then once it's there, you'll have a Snowflake, for example, and the Snowflake will read from that Iceberg data and will be able to decrypt it when you need it. So we can have it encrypted before it gets to the Iceberg and decrypted after it leaves Snowflake, for example. So it's really an end-to-end encryption while allowing you to do the access control authorizations you need for that data. That's the idea of encryption here and of end-to-end encryption, right? So we can help customers comply with their sovereignty laws because data needs to be decrypted in country and maybe encrypted in country. So you can do the ingestion in country, encrypt it, move it anywhere you want, and then manage it with a Snowflake engine. When you decrypt it, that's where we are putting that enforcer in this way. In this illustration, it's a gateway that can sit somewhere, and wherever it sits, that's the decryption point. And of course, by the way, on that point, we can apply the access control policies with ABAC. That's the idea. Those are the two phases we have here. So when we do those access controls, we can actually run a SQL rewrite, right? So we can say, on top of what you already have, I want to reduce the number of rows you see. You're not allowed to see VIP customers. You're not allowed to see VIP customers that are not in your own country. We can also set some filtering, right, for row-level access control. You won't be able to see employees of the companies that are also customers. We'll have dynamic attribution capabilities, so we can get from your SSL solution, let's say you did multi-factor authentication with Okta. We will see the group memberships, we will see your title, we will see your risk level within the SAML assertion or the OAuth token, and we can use those those information items to make a decision, right? For example, if your risk level is high, we can now start showing you only encrypted data and not clear text data. Then, of course, we can do column level format preserving encryption to allow you to do zero trust and data sovereignty. So people who should not see clear text data will not see that clear text data. They'll see encrypted data or will not see that data at all. And we are able to do real-time monitoring, which you can correlate to the Snowflake logging, right? So Snowflake will tell you what the users are doing. We will tell you what users are doing. If you see any kind of differentiation between the two logs, you know something is happening there, because usually when there's a hack, the first thing hackers will try to do is change the logs, right? Say that didn't happen or nothing happened, or even change the log to say everything looks normal, because that's what they want you to see in the log. So you have two logs now that you can compare and correlate and find any kind of differentiation between them. So that's a nice thing. Last thing here is that we have our own repository of attributes. You can push new attributes into that repository using APIs. So whenever you need to do it, we have a customer now, a Swiss customer, who's telling us, as long as you're in Switzerland, you can see the data in clear text. But if you're on a train going somewhere else. Once you cross the border, I want to know about it, and then I'll start showing you encrypted data. So we can push those attributes in real time into SecuPi. And once we know about this new attribute, we can apply the policies based on that new attribute. So we'll know you're no longer in Switzerland, you're somewhere else in Europe, and now the data becomes encrypted when you view it. That's the idea there. So that makes it pretty easy for us to apply any kind of access control policy and any kind of data de-identification need for the complex environments. If I'm going to look at the big picture, we have an ingestion point where we can have different types of agents or enforcers encrypting the data, creating an Iceberg file format. So now this Iceberg file format can be consumed by multiple analytics, cloud analytics platform, right? This is where we can also enforce who can access that, including privileged users, right? Because maybe you have a privileged user in Snowflake, maybe you have a privileged user in BigQuery. Those privileged users doesn't mean that if they can override the policies of the system, doesn't mean that they still need to see that data. So that's why we can do kind of a defense in-depth approach where we can control even privileged users in each one of those systems. But then when the end users needs to access it, we can allow them access to the data in the clear or encrypted or tokenized or generalized according to policy in country. That's the idea here, right? So we can encrypt the data, making sure that privileged users inside the environment have tight controls and logging. And then for analytics users have the ability to see the data that they need to see according to the policies that were approved and authorized by the organization. That's the high level of data protection for Iceberg data. Any kind of feedback on that, Mike? What do you think?
Yeah, so very much aligned. Open table formats are still very relatively new in the industry and definitely new to a lot of the organizations adopting. So these access control models continue to evolve to enforce the right level of governance and then also the right confidentiality and access control downstream.
Makes sense. Makes sense. Okay, good. So I think just to show some illustration of what can happen with de-identification, we have different protection capabilities. One of them is deterministic and reversible method. So in this example, when you're doing tokenization, I can take a number, let's say this is a credit card number, and I can tell my what we call the rewriter, my de-identification technique, to keep the first 4 digits, to keep the last 4 digits, but everything else will be tokenized. Same way, I can do it with an email, say, take the email, leave the last four characters as is, but encrypt everything else, right? Or as you see here with the social security number, I can take one social security number and move it to a different social security number. In all of those cases, it will always be the same, and you can always reverse it if the user is authorized. But then we have different types of encryption. So when you get an encryption, you'll get some sort of a ciphertext, which is, again, deterministic and reversible. It's just not very familiar, right? You'll see it, you don't really understand what's happening here. Then we have a very small type of data. So if you have a blood type, you don't have a lot of blood types, right? A plus, B plus, A minus, B minus, right? AB plus and minus. So there are not many options. That means in order to encrypt it, I need to create something that is a little bit bigger, and we have the ability to do that as well. And another example here is to do what we call type-safe protection. So for example, when you have a birth date, it would look like a birth date. When you have a date, it would look like a date. When you have a credit card, it would look like a credit card. Of course, we can make it random if you want to. So if you don't want it to be deterministic, we can make a random number. That's really good for test data management. So if you want to create test data, that's a good option as well. And as I said, type-safe encryption, date, if you're just preserving the format, a date can be something like that, right? The 13 of the 38 months. So that's not a good date for a database. Or if it's a byte, but that byte now is bigger than a byte, then you're not making a type safe for a byte. That's the idea behind that, a type safe solution here. And the last illustration I have here is about that data sovereignty. We have a customer in Japan that wanted to make sure that all of the data is encrypted, and it can be decrypted only in Japan. So they have a Snowflake environment. That Snowflake environment sits in the US because it's a global company. The data is being encrypted in Japan and then being shipped into Snowflake. Snowflake holds it, processes it, do everything with it. But when they decrypt it with their Tableau or Power BI or anything like that, they have a gateway that sits only in Japan. And only that gateway in Japan can decrypt the data for them. That's how they make sure that that sovereignty is being complied with. That's the idea here. So I think this is kind of what we wanted to talk about. And now maybe it's time to show you how it works. Okay, so I have two users here. I have a user named Jill. There you go, Jill. She's an analyst, and she's trying to access a table called Customer CS Enc under the public schema. So when she runs this, she will see this data. She'll see an email that is encrypted. She'll see a credit card that is encrypted. Looks like a regular credit card, but it is encrypted. She'll see social security number, which is encrypted. Some of it is masked. She'll see department encrypted, and she'll see a birth date that is generalized. So you can see all of the birth dates are January 1st. The other thing you can see here, that she can see only customers from Canada and Mexico, right? Only customers from Canada and Mexico. If you look at the social security number, platinum and employees are masked. And then silver and gold members are not masked, but they are encrypted. So just in high level, this is what's happening here. If I'll go now to my second user here, this is Jake. Jake is in finance inside Snowflake, and he's going to run the same query. So running the same query, what I'm going to see is that Jake can see the emails in clear. He can also see the credit card in the clear. I'll show you that later on, that it is in the clear. And he can see the social security number in the clear. He can see the department in the clear, and he can see the birth date in the clear. But he sees only customers from the US, so only US-based customers. And if one of them is an employee, like here, it will be masked. The social security will be masked. So he does have some masking here, and that's only for customers who are of type or status employee. So this is what we see that is happening inside Snowflake. Now, there is no special permission in Snowflake. This is all happening from SecuPi. Let's see why. So if I'm going to my dashboard, I'll see what happened in the last few minutes. So a minute ago, that was Jack. Let's see what Jack did. So what we see for Jack is we got USA and C4. We got from Active Directory an attribute about the user Jack that he is assigned to the country of USA, and he has a clearance level of C4 that's a high level clearance. So let's say he's a manager or a director or a VP in the company. We also see where he came from and what's his role inside the database. And we also see what was the select query that he ran. Now we can see what did we do for him. Because it was an encrypted table, we had to decrypt the information for him. That's what we see here. If we look at Jill, let's see Jill. So if we look at what happened to Jill, so this is an example of Jill. So for Jill, again, she did the same select from customer CS Inc. But because the attributes we got from Active Directory was that she's assigned to Canada and Mexico, we actually did a SQL rewrite here, and we switched the select from to select from this view. And the view is saying the country is in Canada and Mexico. That's why we see Canada and Mexico. We can also see that we didn't decrypt much here. We just replaced a few social security number with XXX, and we rounded the birth date. Remember, she saw January 1st, so that's what we did. We didn't do anything for the email address or the department or the social security number or the credit card because they're already encrypted in the database, and therefore that's what she saw. How did it happen? Very simple. We have a column level access control rule. We have two of those. Let me close that so you'll see. By default, everything is encrypted. But if you can match the clearance of the user to the clearance of the data, that's here, match the clearance of the user to the clearance of the data, then see it in the clear. But if you cannot match them, then you'll see it encrypted. Just to show you an example, if I'm going to make this masked, click OK and save. Then if I go back to Jill and run the same query again, remember, look at that email. This was the email before. Run it again. Now it's masked, and the credit card is masked, and the department is masked, and the birthday is masked. So everything is masked. Let's go back here. So this was the first rule, right? The rule that we call column level access control. We also have row level access control. This is where we did the country match. So we said, take the attribute of the user country and match it to the column called, a field called country. That's how we reduced the countries that Jack can see. That was US, and Jill saw that was Canada and Mexico. The last one we have is what we call object level access control. So in object level access control, I can decide what you can and cannot do within the database. For example, I created a rule here to say, if you have a clearance level of C4 and the table name contains the word top secret, then do not allow select, drop, insert, update, or delete. So let's go to Jill for a second and have her do a select query. So if Jill will do a select query on a table called top secret 21, what you'll see is an object level access denied, user is not authorized. And you can see this is a SecuPi message, not just from Snowflake, it's from SecuPi. So our object level was the table. The table contained the word top secret, and Jill doesn't have the clearance C4. That's why she was denied. We'll be able, of course, to see it in the dashboard. Here, an authorization happened here, right? And what we call an OLAC event, an object level access event, happened because she was trying to get access to this top secret table. So I think I'll stop here. This was our demo for SecuPi data security platform for Snowflake. Thank you everyone for watching.